Hello students, welcome back to our class. We are back with new lesson, that is carbon and its compound. So in this lesson we are going to discuss about carbon and the different kinds of compounds it makes. Although you have learnt about it that carbon forms organic compounds only because it shows covalent bonding. So we are going to discuss about those compounds and respective examples in both the forms of carbon, that is inorganic carbon also and organic carbon also. So let's start the session, and first of all we will be discussing about its significance, that why this carbon is important and where is it found, like that is about occurrence of carbon. So this is the very basis of life. We as human beings or any other kind of organic matter is made up of this main element carbon, and along with carbon we have hydrogen, oxygen and other elements as well. So that depends on the different kinds of other elements present in the different compounds, but this carbon is going to remain same. So that is why it has a separate branch that is known as organic chemistry also. And when we are discussing about carbon as inorganic carbon, then also it is nothing less but so many compounds of this inorganic carbon is also existing in nature. So that is why it is said in terms of organic carbon that it is the very basis of life. Since matter constituting all living things, we know this, everything is made up of matter, it has mass and occupies a space. So that mass has carbon in it. Whether plants, animals, they all contain carbon. Therefore, it is not surprising that it is one of the most widely distributed element on the earth. So it has its percentage in the atmosphere also as carbon dioxide, 0.03%. Then in the earth crust also it is found as mineral ions, different kinds of minerals are present. So it has existence everywhere. In fact, it is the third most important element, and that is after oxygen and hydrogen for the existence of life on the earth. So we have already discussed this term. This carbon is derived from the Latin word meaning decarbo, that is coal. So it is existing from the coal era only, that is from carbon content, that is coke you see and you use in your ancient times also and nowadays also. So from where this word is being derived. If we talk about occurrence in detail now, so it is occurring in the earth crust in the free as well as in the combined state. So this carbon as it is as a solid residue also exists, and in the other form when we are saying combined, so it can exist as carbon dioxide also, it can exist as acid also like carbonic acid, it can exist as a salt also or a mineral that is limestone, calcium carbonate. So all have different percentage of carbon in them. It occurs as coal, diamond and graphite. So these three examples are for existence of carbon as in the free state. Here diamond, graphite, coal all are forms of different forms of carbon only. That we will also study this term, that is they are termed as allotropes of carbon. Allotropes are when an element can exist in different forms, and this phenomena is known as allotropy. So more than one physical form existence of any element is the term allotropes we give. In the combined state, it exists as in the atmosphere as carbon dioxide gas, in natural water as dissolved carbon dioxide also. So when it is dissolved as carbon dioxide in water, there it gets, actually it first forms carbonic acid. We can show the reaction also, that when it is present in dissolved form, what happens, this is water and this dissolved carbon dioxide will result in the formation of carbonic acid, H2CO3. And what happens, this H2CO3 when formed, although it's a weak acid, but it can dissociate as proton and bicarbonate ions. So this bicarbonate ions is also one of the primary carriers of carbon dioxide. Although this reaction is happening in dissolved state in natural water, but you have also learned in respiration, or you will learn about it, that the carrier of oxygen or the carrier of carbon dioxide, the primary source is these bicarbonate ions also. Okay, so that also happens, this same reaction also happens in the blood capillaries to transfer or transport carbon dioxide. Natural gas and petroleum are also one of the sources where this carbon is present in combined form. Natural gas is nothing but methane gas, CH4 is the formula. Petroleum is a combined compound where it is consisting of so many other compounds, like there is paraffin wax, lubricating oil is there, petrol, diesel, gasoline, all different kinds of compounds are there. And then in combined state, this carbon can exist in the biomolecules also. Biomolecules are like when we are saying in food nutrients, then it is existing in the food compounds, food substances such as starch is there, which is a polysaccharide, it's a form of carbohydrate only. Then sugars are there, fats, proteins, vitamins are there, so they exist in the food nutrients also. They also exist as carbonates and bicarbonates. So the bicarbonate ion I already shown to you, HCO3 minus, and carbonate is CO3 2 minus ion. So their existence are found in mineral ions such as chalk is there, limestone is there. Then limestone is also called as marble only. So it has the formula calcium carbonate. Calamine is there, which is an ore of zinc, or you can call it a mineral of zinc. Minerals are what? These are the substances that are found in the earth crust, deep buried in the earth crust. We take them out and then extract the metal from them. So carbonate ore which has carbon of the zinc is known as calamine. Then marble is calcium carbonate. Washing soda is there, sodium carbonate decahydrate is the formula, Na2CO3.10 water, and baking soda is there, sodium bicarbonate. So all these you can see carbon is present in the form of carbonate ions or bicarbonate ions, and they have carbon in it. Okay. Then in clothing materials also it exists in combined form, like cotton, silk, and other kinds of textile fibers are there in which it is found. So this carbon is very unique non-metal, and because of certain characteristics, although you will study about those exceptional characteristic of this carbon due to which it is able to form more than 1 lakh compounds in the nature, and that too only organic ones. Inorganics are separate category. So more than 1 lakh organic compounds exist, that's why it has been divided as a separate category, and those characteristics you'll study in more detail in your 10th class. But right now if we have to mention certain characteristic, whether because we are calling it a unique non-metal, so this uniqueness exists because of, first of all, its configuration. Its atomic number is 6. Let's see those unique characteristics also. Because we are saying it is unique, carbon has 6 atomic number, you write its configuration as 2 and 4. So this 4 valence electrons that we call tetravalency, because carbon has 4 valence electrons, so we call it tetravalent. And because of these 4 electrons, it neither gains 4 electron, it neither loses 4 electrons. It exists, this case doesn't exist. It exists as sharing. These 4 electrons are shared with other elements when it has to show bonding. So, because in both the cases, either lot of energy is required or more energy is being dissipated. So, that's why carbon doesn't prefer electrovalent bonding, and that's why it goes for covalent bonding where sharing of electrons takes place. So, this tetravalency makes it a unique non-metal, because these valence electrons are the middle ones, right? Because we need an octet for an element to become stable, and 4 is just half, that is a halfway of achieving any octet, right? A stable configuration. So that's why it shows first point, because of tetravalent it has this unique nature. And when we are talking particularly about organic compounds, then it can arrange itself, it can combine itself with the same kind of carbon atoms also to result in the formation of either chains, or it can result in the formation of ring also, it can result in the formation of branching also. So that characteristic is catenation power. The term you will study, although the meaning is just this only, that is self-linking property of any element. is known as catenation. When an element is capable of joining a same kind of elements with itself, that property is catenation. And this carbon has this property maximum among all the elements of the periodic table. That is why again it is a unique non-metal. And one more property is there, that is isomerism. It is capable of forming isomers, lot of isomers that results because of this different structure formations. And that although this term will be dealt in detail in your 10th class only, but these are 3 points that makes this carbon a unique non-metal and having widely differing forms and properties. Mankind has known this carbon in the form of charcoal and soot ever since the discovery of fire. So from there only its existence has been established. We know this carbon in the form of charcoal and soot, very common forms. Although this carbon constitutes only 0.03% of the Earth's crust, it forms an enormously large number of compounds. The number I have already mentioned, that so many mineral ions are or mineral substances are capable of being formed of this element, and then there is a separate category of organic compounds. The number is so large that entire branch of chemistry called organic chemistry, just now I have mentioned, is devoted to the study of carbon and its compound. So in fact, for the convenience of study, all compounds are classified. All the compounds of whatever the number of compounds found in nature, they are classified into 2 categories, organic and inorganic ones. Organic ones basically only made up of elements carbon, hydrogen, oxygen, and certain other like some halogens, chlorine, bromine, iodine, fluorine, or nitrogen, phosphorus, sulfur. That's it, not more than this. And inorganic chemistry, inorganic compounds have zinc, copper, mercury, other kinds of elements as well, right? So that's why that category is organic compound category being different. Organic compounds, they essentially contain carbon. Essentially, significantly, it has carbon. That is the necessity. A few examples of useful organic compounds: biomolecules, carbohydrates such as starch, or fatty substances are also there. Alcohol, dyes, detergents, soaps, plastics, wax, vinegar, polymers, plastics, all are examples here. Clothing materials like nylon, silk, wool, cotton are including this carbon in them. Then paper, polythene, perfumes, disinfectants, and medicines. So these all are the substances that you use in your daily life. They are part of your routine and they are made up of what? Carbon only, along with other elements, and these all fall under the category of organic compounds. So from the examples, the wide category of examples signifies its diversity. This carbon can exist, it is made up of this carbon and in the combination with other elements, but see how much diverse is this element in the form of different compounds it shows. That's why a different separate category is made for these organic compounds. So these are categories mentioning the names of some compounds containing carbons, and we call these organic compounds as hydrocarbons. So from the term, hydro is for hydrogen, carbon is for carbon. So carbon, hydrogen containing compounds are hydrocarbons, and they are basically the simplest type of organic compounds, and these are known as these: methane, butane, ethene, ethyne. So they can be saturated, unsaturated. All these terms will be dealt in detail in higher classes. Saturation and unsaturation means you will categorize them as either having single bonds, double bonds, triple bonds in this way. Then alcohol category is there, acids category, sugars categories are there. So these all are examples of organic compounds only. Then inorganic compounds, these are like carbon dioxide, mostly gases, and then minerals are there. Carbon monoxide is there, calcium carbonate is there, sodium carbonate is there, copper carbonate, zinc carbonate, so many mineral ions are present. So this carbon forms large number of organic compounds because of the ability of carbon to form long chains. Although I have mentioned in the starting, it is just written that through sharing of electrons. This unique property is catenation. Carbon atoms can form long chains by sharing their valence electrons with other carbon atoms. So that CCC chain which I was just showing to you, it is a part of covalent bonding only, and this is a result of property catenation, which is maximum in this carbon. The strength of carbon-carbon bond is very large. It is a very strong bond. Bond strength of carbon is very high, and because it will require a lot of energy in order to break this bond. So that's why it is capable of existing in chains. It's not easily broken down. In addition, petroleum is a mixture of carbon compounds which are found in liquid state. So I have already mentioned about liquid carbon, like in petroleum case, in the form of petrol, diesel, gasoline, lubricating oil are part of these petroleum. Also, vegetable oils, these are liquid forms of carbon compounds. Then gaseous forms of carbon such as carbon dioxide, carbon monoxide is there. Then carbonates and bicarbonates in the form of any solid substance for inorganic compounds exist. Some useful carbon compounds are PVC, polyvinyl chloride, that is a polymer only, and you know it in the form of plastic range. So PVC bottles are there, containers are being made, and they are very highly because durable, and they are resistant to heat, air and moistures. That's why they are more popular. Full form is polyvinyl chloride. It is used for making pipes. Bakelite is also there. So the handles of metal containers which you use for cooking are having these bakelites. So it's tough, resistant plastic which can be molded into different shape. It is used to make cameras, telephones, plugs, etc. So wherever it is being required to have an insulation, then this bakelite is being used. These are also polymers only, and these are made up of carbon only. Then we have polythene, also again a polymer. This is another important compound of carbon with various uses. All you must be familiar with the word polythene. You must have heard about the polythene and you use it also. It's nothing but this polymer, polyethylene, often used to make carry bags. Carbon fiber is there. So organic textile fibers, they are heated to make silky threads of pure carbon, so that have a shiny appearance in the form of the fabric that is being made from these fibers. These fibers are combined with other materials to make them more strong, so such as like plastic and light composite materials which are useful for objects where tightness, strength are important, like from tennis ball to small aeroplanes also. So this is the wide diversity of this carbon and many uses where it forms, where it is being found in the form of different compounds. Now the term after occurrence, we are going to discuss about that this carbon can exist in many forms, right? And the term I have used, allotropes. More than one physical form of any element is allotropy, and this carbon has 3 allotropes, and this will fall under the topic that carbon has 2 main forms, crystalline and amorphous. Crystalline when it has a crystal, particular shape, geometry is there. Amorphous when it doesn't have a particular geometry. So under this only we are going to discuss this. Allotropy is defined as phenomena due to which an element exists in 2 or more forms, like diamond and graphite, the more common examples for allotropes of carbon. You know very well how graphite is black in color and diamond is a lustrous substance. Graphite is soft and slippery. Diamond is the hardest substance known on earth. So that is the contrast of properties, but they are made up of only same kind. That is carbon element only. The material with which it is made up of is same, but still how these atoms are combining together to form these materials, that is the difference that makes them different compounds, different properties they contain, and the term allotropy. Where these elements when have more than one form in the same physical state, like solid only, diamond, graphite both are solid in nature with identical chemical property, they will be having identical chemical property. Why? Because they are made up of similar kind of element, but will be having different physical property because the arrangement of those similar carbon atoms is different in both the categories, or any other allotrope if it exists. There are different allotropes also. Such forms of element are known as allotropic forms or allotropes. We'll see ahead different examples. Some elements they exhibit allotropy, like there is carbon, there is phosphorus and sulfur. These are the three main elements found in the periodic table which shows allotropy. The allotropes of carbon are divided as crystalline and amorphous. Amorphous are non-crystalline ones. These two broad types are subdivided into a number of specific allotropes. That is the chart being shown here for showing the different forms. Like carbon has crystalline and amorphous nature. Crystalline forms having particular geometry like diamond is there, graphite is there. Fluorines and carbon nanotubes. CNTs are carbon nanotubes which are found in application nowadays being very popular. Then amorphous ones are coke, charcoal, carbon black. These are different examples. They all are different materials having different physical properties, different strength and different applications, but they are made up of similar element, that is carbon only. That is the uniqueness of this carbon. All these forms of carbon, they differ in their physical properties, but when burnt in the presence of oxygen, they are all going to produce carbon dioxide because they are made up of carbon, right? That's why, with the release of heat. So diamond, graphite, coal, coke, when they are burnt in the atmosphere of oxygen, that is a heat sign, they are going to give carbon dioxide because they are made up of what? Just mentioned that they are made up of this carbon element. And this carbon is burnt in an atmosphere of oxygen gas. So they are going to combine together. If there is more oxygen, they are going to form carbon dioxide. If there is less oxygen, they are going to form carbon monoxide. That is the case only. So that is the reaction also being written here. Since we have used the term crystalline carbon, so what is a crystal? Let's understand that also. A crystal is a solid whose particles, either atoms, molecules or ions with which it is made up of, are arranged in definite pattern. So they will be having definite pattern, like this pen has a definite pattern, this presenter has a definite pattern, this blackboard has a definite pattern. So it has a definite shape, no, because it's a solid and outwardly expressed by a geometrical form. So it will be having faces, sides and all. So that is a characteristic of a crystal. Like sodium chloride is there, sugar crystals are considered crystalline because their molecules have cubical shape. So let's start with the crystalline allotropes of carbon. Very first example we have graphite. Graphite is a crystalline form. Natural graphite is extensively found as mineral plumbago in both Sri Lanka and Siberia. In India, graphite is found in Jammu and Kashmir, Bihar, Odisha, Rajasthan and West Bengal. So these are the occurrence of this graphite, sources of graphite in nature where it is being found. If we have to prepare graphite, so it is prepared artificially, this pure graphite, by heating powdered coke. Coke is what? Carbon only. So which is mixed with little sand, and because we have to retain the heat, that's why sand is being used, and iron 3 oxide Fe2O3 is being used in an electric furnace to a temperature of 3000 degrees Celsius. So sand is being used in order to absorb the heat and make it to retain that heat for longer duration of time until it is converted into graphite. Structure of graphite, if we discuss, it's a flat hexagonal layer of structures, and this is the structure being shown for graphite. It has a hexagonal network of carbon atoms in it. In a graphite molecule, each carbon atom is linked with 3 neighboring carbon atoms, thus forming a hexagonal arrangement of atoms. Why we are saying 3? See, carbon has 4 valency, right? We have seen its atomic number 2, 4, right? 4 valence electron, 4 is the valency, that means show it by 4 bonds. But what happens that when it is forming graphite, so it is actually having only these 3 valency being occupied. This valency is vacant. It doesn't form any bond. So it has a mobile free electron in it, due to which we'll see ahead it has conductivity also. Presence of mobile electrons give it a conduction power. These hexagonal grouping of carbon atoms are arranged in layers of sheets which are piled one on the other. The layers are held together by weak forces, such as they can slide over one another. That is why graphite is considered soft and slippery also, and can be used as a lubricant in machines and in pencil leads also. So that it is smooth, that's why we can write easily without any feeling any friction. Also in a graphite molecule, one valence electron of carbon is free. We have just seen the diagram, thus making graphite a good conductor. Next is carbon. Carbon binding force is strong in the hexagon itself, in graphite only. So melting point and boiling point are high. So that is a strong bonding it is showing. Properties, if we discuss for this graphite, it's a grayish black opaque substance with a metallic luster. Density is 2.39 gram per centimeter cube. You need to remember at least 2-3 points from this category. It is stable to heat and has very high melting point of 3700 degrees Celsius. It is soft and greasy to touch. It marks a black stain on paper. That's why it is being used in making pencils, lead pencils. It's a good conductor of heat and electricity. Uses, if we discuss, so we relate the uses from the properties only. So from there you can easily identify with petroleum jelly to form graphite grease. As a lubricant we use it. For making electrodes of electric furnaces. For making crucibles for melting metals due to its high melting point. So we use this carbon graphite in making crucibles. Crucibles are the laboratory apparatus only. It's a type of a vessel in which you keep the compound, and that vessel is crucible, which you call it, is kept in a muffle furnace or kind of furnace where you provide high temperature, where you need to perform the process of carbonization or any other process for say. So that crucible, this carbon can withstand so much high temperature. That's why it is being employed in making these crucibles due to high melting point. For making more than 700 degrees Celsius, carbon brushes for electric motors are being used. For making pencil lead, because it can mark black on the paper, it leaves a stain black. It is used in nuclear reactors as moderator to slow down the speed of neutrons also. So this concludes our lesson here about allotropes of carbon, and before that we have discussed about the occurrence of carbon. So in the carbon and compound, this lesson we will be dealing in the next session about the next allotrope of carbon, that is diamond. So till then revise these topics. We'll meet again. Thank you so much.